Hi guys, good morning. It's another lovely Thursday and we're going to be having mathematics today. Okay, so but before that, I want us to look at just one error, one common math error that some of us might be making. So let's just look at it together. Now, I'm raising a number to a given power. Okay, so when you're trying to raise a number to a given power, it's not equivalent to multiplying by that power. So for example, x raised to the power n is not the same as x times n. So you just need to be very careful to not make that mistake when you're working with powers. Okay, so for example, 3 raised to the power of 2 is not 3 times 2. It's not equal to 6. 3 raised to the power of 2 is not equal to 6. Okay, it's not 3 times 2. Instead, 3 raised to the power of 2 simply means 3 times 3. That's 3 has a power, has a power of 2, so you should multiply that number by itself. Okay, so it's 3 times 3, which is 9. And if I say 3 raised to the power of 3, it's 3 times 3 times 3. Okay, so that's how it is. I know some of us are wondering, oh, this is very easy, but yeah, it's a common mistake. It's a common mistake that some of us might be making. So if you have been making this mistake, I want you to correct it today, okay? All right, so let's move on to what we want to start with today. What do I expect you to know? Okay, so number one, you should be able to remember the applications of the laws of indices, and number two, you should be able to solve, equations that involve indices. Okay, so you should be able to solve equations involving indices. So yeah, our topic for today is laws of indices. Laws of indices. Okay, but I believe you have done some laws of indices from junior mathematics. So I want you to just, as you're watching, I want you to just flash back and try to remember any one of the laws, and just try to remember, see which one you can remember. Although we're going to take a quick recap of all the laws again, just so that you can remember them. But if you can still remember any one of them, just try to think back and just say them before we start. And it's important that we learn these laws of indices because we need to understand the relationship between, first of all, we need to be able to use it to solve problems here, and then we're going to be doing logarithms soon. So it helps to, completely understand, we need to understand the relationship between the logarithms and indices. Okay, so it's important that you pay attention to every one of these laws. Okay, so law one, let's start. Law one simply is the law of multiplication, and it simply, in essence, says that multiplication changes to addition. Okay, but let me break that down. So when you have two numbers multiplied together, okay, these numbers have the same base. Okay, as you can see, we have x raised to the power of a times x raised to the power of b. So there's a common thing there, and that thing there is x, or that variable there is x, and it's called the base. It's called the base. So take note that if you're going to be using this law, the bases, that's the two numbers that you're going to be dealing with, should have the same base. Okay, so x raised to the power of a times x raised to the power of b is equal to x raised to the power of a plus b. So that's the law of multiplication. But take note also that this law only applies when x is not equal to 0. Okay, x shouldn't be equal to 0. Okay, but x can be any other number. Okay, so that's that for the law of multiplication. Let's see how we can apply that in an example. Okay, so for example, we have 10 raised to the power of 3 times 10 raised to the power of 6. Okay, that's actually got can be calculated, directly. We can say 10 raised to the power of 3 is 10 times 10 times 10, and 10 raised to the power of 6 is 10, multiplied in 6 places. But oh, that's a, that's a whole lot of work. Okay, so we need to, another thing about the laws of indices is they help us to simplify our work. Imagine in a scenario where you have 2 raised to the power of 59 and minus or times 2 raised to the power of maybe 25. Imagine having to start evaluating one after the other. That's going to take you a long time. But with these laws of indices also shorten the period it takes you to solve these problems. So here we would have 10 raised to the power 3 times 10 raised to the power 6 equals 10 raised to the power 3 plus 6, and that would give us 10 raised to the power of 9. Of course, we know that 10 raised to the power of 9 is 10 multiplied in 9 places, but let's just leave it this way, 10 raised to the power of 9. Okay, so that's that for law 1. I hope it's looking good. Okay, so law 2 now. Law 2 now is the law of division. It's the, should I say it's the complement of the previous one? Yeah, well, something like that. Okay, so this, instead of multiplication, now says that x raised to the power of a divided by x raised to the power of b equals x raised to the power of a minus b. And of course, division in this case becomes a subtraction of the powers. And also take note of that the conditions apply here. The base should be the same and x shouldn't be equal to 0. So that becomes okay, let's take an example and see how we can use this. So for example, 35t raised to the power of 5 divided by 7t raised to the power of 2. So you can rewrite that in a fractional form. Put 35t raised to the power of 5 on top and put 7t raised to the power of 2 underneath. Now, but 35 divided by 7 is 5. Okay, so don't get confused. In case you are thinking, oh, how do we just subtract the powers? No, you do with the numbers first. 35 divided by 7 is 5. Then we have t as a common letter to the two terms in that expression. So t now would, t raised to the power of 5 will be used to divide t raised to the power of 2. So that becomes t raised to the power of 5 minus 2. Okay, so what we have is 5t raised to the power of 3. 5t raised to the power of 3. Okay, so just understand that when you're talking about division of two numbers that have the same base raised to the and they're raised to a certain power, or they're raised to certain powers, you can simply evaluate that by subtracting the powers, as long as their bases are the same and x is not equal to 0. Okay, let's quickly move to the third law now. Now, this law is, oh, wonderful. It's it's an all-important law. It's an all-important law. There's a song okay, it's not really a song. It's just 2 lines, a call and response actually. And the rest of the power of 0 is 1. Oh, my voice is he's a bit on the cracked side today, but I usually sing that and it helps my kids to remember. So I tell them anything the rest of the power of 0 is, and they have to tell me 1. So it's quite funny. Like okay, I was going to say that if you want to learn math and you're finding it difficult to understand some concepts, okay, you understand, but you want to be able to remember them, you can form them into songs, you can form them into, a kind of poem. You can just use 1 or 2 methods that will infuse the fun into into what you're learning. Okay, so x raised to the power of 0, that's any term raised to the power of 0 is 1. And this is an awesome phenomenon. So x shouldn't be equal to 0. Yeah, remember that. So anything raised to the power of 0 is 1. I think that's quite an easy one. So let's just take one example, very easy example. 8 raised to the power of 7 divided by 8 raised to the power of 7. Okay, first of all, we know that division of the two numbers with the same base will change to a subtraction of their powers. So we have 8 raised to the power of 7 minus 7, and that becomes 8 raised to the power of 0. And we know, of course, that Anything raised to the power of 0 is 1. Okay. So let's continue. So law 4 now. Let's look at this one. This is called the law of a negative power. So now you're dealing with a number raised to a negative power. So we have, for example, x raised to the power of minus n. How do you get rid of that negative and then simplify further? Okay, it's very easy. It's easy peasy. If you want to get rid of the negative sign that's in front of your power, all you need to do is find the reciprocal of the base. So for example, x is our number, isn't it? X is our number. So all we need to do here is find the reciprocal of x. And of course, when we say reciprocal, we mean 1 divided by that expression. So 1 over x. Okay, so when we say 1 over x, then the negative in front of our n disappears. So you can see that 1 over x raised to the power n. Remember, x shouldn't be equal to 0. Okay, so 1 over x raised to the power of n now. The negative sign is gone. Now, so that's how you get rid of the negative power. Now, in a case where you have a fraction and you want to get the reciprocal, well, how do you do it? So for example, you have 2 over 3 or 5 over 6 and you want to get the reciprocal of maybe 2 over 3. How do you get it? Okay, now let me tell you, in case I know some of you know that. Okay, so for 2 over 3 is a fraction and you want to get its reciprocal, all you need to do is, since you're supposed to divide the number by 1, 1 over the expression, you can simply turn the fraction upside down. So the numerator will become the denominator and the denominator becomes the numerator. So when you have 2 over 3, okay, the reciprocal is 3 over 2. It's 3 over 2, so that makes it easier for you to remember. Let's look at some examples to make it easy to understand. Okay, so look at this. We want to simplify 5 raised to the power of minus 3. So we want to get rid of the negative so that it can help us to solve better. What do we do? So all we need to do is find the reciprocal of 5. Find the reciprocal of 5, and that is simply 1 over 5. That's all. So 1 over 5, and then the minus in front of the power disappears. So 1 over 5 raised to the power of 3. Okay, so 5 raised to the power of 3, of course, is 5 times 5 times 5, which gives us 1 over 25. Okay, now I hope that's good. I hope you're good with that. Okay, so let's look at another example that involves a fraction now. So in this case, see, we have 3 over 2 raised to the power of minus 3. So raised to the power of minus 3. To get rid of our negative power, what we need to do is to get the reciprocal of 3 over 2. So we're going to switch places. The numerator becomes the denominator and the denominator becomes the numerator. So instead of 3 over 2, we would now have, okay, 2 over 3. 2 over 3. Okay? So, and then the negative in front of the power disappears. So we have 2 over 3 raised to the power of 3. So 2 raised to the power of 3 and 3 raised to the power of 3 gives us 8 over 27. So 8 over 27, and that's our answer for that example. I hope you're following, and I hope it's sinking in. Okay, so like I said, I'll leave it up to you to try to form 1 or 2 songs, poems about these laws. You can even make it into a rap if you love the arts. You can make it into a rap song, and you might even be able to share it with us. Just tell us what you're up to. Okay, so let's look at the 5th law. Now the 5th law is the law of the product of exponents. So when you have x raised to a power, and then all of a sudden you just see another power raised to that, the whole expression is raised to another power. So when you have, for example, x raised to the power a, and then everything is now raised to the power of b, what do? Do you get confused? No, you don't. You simply multiply the powers. you multiply the exponents. So you would just have a times b. So that gives you ab. So you simply say x raised to the power ab. You just tell the math problem, oh, I know how to solve u. Okay, all I need to do here is, okay, multiply the exponents. Oh, yeah, and I'm done. So a times b, that's ab, and I'm done. So x raised to the power ab. Okay, and x shouldn't be equal to 0. Okay, so then we have, let's take an example, a simple one. So we have, I said simple, yeah, it is. So we have minus 5d cubed, now all raised to the power of 2, or all squared. So what this simply means is that the square outside the bracket affects every term inside the bracket. When you see a bracket, every term inside the bracket is affected by the power outside the bracket. So we have here minus 5 squared and then d cubed square. So minus 5 square, all square now means minus 5 times minus 5, because the square also affects the minus sign. So that gives us 25, and d cubed square means we're going to do a multiplication of the powers of the exponents. We're going to do a product of the exponents for d cubed square. So we would have 3 times 2 here, which will give us 6. So this is d raised to the power of 6. So that's our final answer. So that's our final answer there, 25d raised to the power of 6. Okay, so that's law 5. Let's go on to law 6. Now, law 6 says the law of the fractional power. The one we raise, actually there are 2 of them, but let's start with the first one. So when you have your base, your number, raised to the power of a fraction now, and a simple fraction in the form 1 over n. 1 over n. How do you evaluate that? Oh, some of us might be thinking and wondering, okay, what do we do next? Okay, what you simply do is that the number, the fraction, the denominator of the fraction, that's if you have 1 over n, the denominator is n, so that denominator becomes the roots of that base. So x raised to the power of 1 over n is simply n, that's the nth root of x, the nth root of x. Don't worry, you'll see an example to get easier. So x shouldn't be equal to 0, remember that. And I want you to understand something about these laws. For you to become very conversant with them, the key is to practice. So practice, okay? Practice. So practice with them. You don't need to start trying to cram them or trying to memorize them. But that's one point that is important if you would want to get it properly. But another route is to simply practice with these laws, and then it becomes a part of you. So you just need to recall what you have practiced and then apply it to problems. Very important. So here, x raised to the power of 1 over n is nth root of x. So let's look at an example to help you understand better. Okay, simplify 8 raised to the power of 1 over 3. Okay, that becomes, and okay, 16, I put 2 examples, 16 over 81 raised to the power of minus 1 over 4. Okay, so let's start with h raised to the power of 1 over 3. Now, h raised to the power of 1 over 3 simply becomes cube root. The 3 is the denominator, so that becomes the root. So cube root of 8. Cube root of 8. That's, okay, a number that we multiply together 3 times to give us 8. Okay, so cube root of 8 is simply 2. So cube root of 8 is simply 2. That's an easy one. Okay, now, but the second question is 16 over 81 raised to the power of minus 1 over 4. Now, our first duty there is to, find the reciprocal of 16 over 81. That's, okay, switch the places of the denominator and numerator. So that gives us 81 over 16, now raised to the power of 1 over 4. The minus is gone. So you can see we are applying the negative power law here also. So when we do that, we can then, use our law 6 here, and then we'll say 4th root we're going to be finding the fourth root of 81 over 16. Okay, we're going to be finding the fourth root of 81 over 16. So we're looking for a number that we multiply together 4 times to give 81 and 4 times to give 16. So fourth root of 81 over fourth root of 16. You know, this is possible when we are talking about square roots, roots in general, surds in general. So we can split like that, and then we can say fourth root of 81 is plus or minus 3, and fourth root of 16 is plus or minus 2. So our answer is plus or minus 3 over 2. Plus or minus 3 over 2. It's important that you take note of that. When you have the root, an even root, like a square root, a fourth root, you should have two possible values as your answer, the positive component and the negative component. So for example, the square root of 4 is plus or minus 2. The square root of 9 is plus or minus 3. So just take note of, you know, that. Okay, let's go to law 7. Okay, law 7. This is also a law that has to do with a fractional index. So you have a fractional power here. Now, in this case, now you do not have 1 over n as your power. You have m over n. So there's a number in the numerator, m, and there is a number in the denominator, n. So what happens is n still sticks as our roots. Remember we said n becomes a root in the previous one? Good. So n still sticks as the root. But now we have m. Okay, so m becomes the number that we raise that expression to, the power that we raise that expression to. So the n is the root, okay, while m is the power that we raise the expression to. So we have nth root of x raised to the power now of m, and x must not be equal to 0. Okay, so let's look at an example. Simplify 8 raised to the power of 2 over 3. Okay, before I say the answer, can you think about it? What are you going to do? 8 raised to the power of 2 over 3. 8 raised to the power of 2 over 3. What are you going to do? Okay, let's go on. I think you should have been able to say something. So let's look at this. What you simply do is you find the cube root of 8. Okay, that's the denominator, becomes a cube root of 8 raised to the power of 2, all square now. Okay, all square now. So cube root of 8 is 2, and all that square, 2 all square is simply 4. 2 all square is simply 4. So that is law 7. That is law 7. So let's take some general examples. I think we've been able to digest some of the laws. They are a bit much, and it's not compulsory that you grasp all the laws at the same time. That's another thing about math. You need to give yourself, you know, the benefit of the doubt and understand how long it takes you in particular to understand some concepts, and give yourself a reasonable pace. If you finding it difficult to learn all the laws, you can always pick the first 4 and say, okay, I'm going to focus on these 4 first, understand them completely, then I'm going to come back and learn the remaining 3. Okay, so take it easy, but just be determined. So general examples, let's take some. This looks difficult, but it's easy. Simplify square root of everything. Square root of 72a cubed b square over 2a raised to the power 5 b raised to the power minus 6. So let's start simplifying the expression underneath the square root sign now. So we have 72 divided by 2 gives us 36. Okay, we're going to start dividing. Then we have a at the numerator and at the denominator, so we'll subtract the powers since it's division. So a raised to the power 3 minus 5, then b raised to the power 2 minus 6. Take note that there's a minus already in b in the denominator. So b raised to the power minus 6. So that should be b raised to the power of 2 minus 6. So that gives us square root of 36 a raised to the power minus 2. 3 minus 5 is minus 2. 2 plus 6 is 8. So that gives us a raised to the power minus 2, b raised to the power of 8. Okay, now let's take the square root into consideration now. The square root of 36, we're going to do the square root of 36, then we're going to apply the square root to the a. So you can see a raised to the power minus 2 times 1 over 2. Square root, and when you have the square root of a number, is the same thing as raising it to 1 over 2. Remember our fractional index, we said 1 over n becomes the root, nth root. So 1 raised to the power 1 over 2 becomes square root. So square root also can be translated back to mean raised to the power of 1 over 2. So that's what we're doing here. So square root of a raised to the power minus 2 is a raised to the power minus 2 raised to the power 1 over 2, and b raised to the power 8 raised to the power 1 over 2. So what is the square root of 36? That's plus or minus 6. Take note of that. Plus or minus 6. And a raised to the power minus 2 raised to the power 1 over 2. You can use what law here? What law here? You're going to use the law of exponents, product of exponents. So you're just going to multiply minus 2 and 1 over 2. Okay? And that will give us minus 1. And 8 times 1 over 2 would give us 4. So this is what you have. A raised to the power minus 1. To get rid of the negative, we can find the reciprocal. So that's plus or minus 6 b raised to the power 4 over a. Plus or minus 6 b raised to the power 4 over a. So we found the reciprocal of a to get rid of the negative in front of the power 1. So that became 6 plus or minus 6b raised to the power 4 over a. Okay, that's a long one. Let's talk about some equations. How do we solve equations involving these indices now? That's what we need to look at. So let's solve this equation. X raised to the power of x equals to 32. Take a deep breath. Breathe in and out. Okay, let's look at the basics. For you to solve any equation involving indices, let me tell you the most important key. If you are trying to find an unknown in the powers or in the exponents, make sure that you find a way to make the two bases, the same. Find a way to make the two bases equal. Do some manipulations until you get the two bases to be equal. What do I mean? You have 8 raised to the power x here, but we have 32 on the other side. And I'm looking for x. X is a power. I'm going to do some manipulations to make that expression in a way that what I have on the base I have, instead of 8, would be a number that I can also have on the right. Okay, so let me show you what I'm saying. So I have 8 raised to the power x equals 32. Now, what number can I get from x from 8 that I can raise to a power? And it should be a number that I can also get from 32 by raising 32 to a power. Okay, so let's see. 2. That number is 2. I can't say 4 because it's not possible to multiply 4 in whole numbers, in a whole number of places. So that will give me 32. So I will just go with 2. So 2 raised to the power of 3 is the same thing as 8, and 2 raised to the power of 5 is the same thing as 32. So we have been able to manipulate to the point where our two bases are the same now. So 2, right? Okay. So 2 raised to the power of 3 all raised to x equals to 2 raised to the power of 5. And we use the product rule here. So 3 multiplies this x. So we have 2 raised to the power of 3x equals to 2 raised to the power of 5. Guess what? This is the bulk of the work. Now that the bases are the same, 2, we can simply equate the powers. Okay? We can simply equate the powers. So that's our goal. Try to establish bases that are the same. Because once you can get that, you can equate the powers. So once we equate the powers here, we have 3x, that's the power here, 3x, and the power here is 5, so 3x equals 5. Simplico. So that is x equals to 5 over 3, and x equals to 1 whole number 2 over 3. Isn't it easy? So remember what I said. The key here is to find numbers that you can use on the left side and on the right side that would make the bases the same. So in this case, we have 2. Okay, we have 2 here. Let's take another one. Solve the equation 2x raised to the power of 3 equals 54. Okay, now this is a bit different here, but let's still see how we can make this work. So we have 2x raised to the power of 3 equals 54. Okay, first of all, you can divide both sides by 2, okay, to get rid of the coefficient on the left side. So if you divide both sides by 2, you would have x raised to the power 3 equals 54 over 2. So that simply means x raised to the power 3 equals 27. Now, when you're looking for the base, the other time we're looking for a power, the unknown was the power, so we try to make the bases the same. Now we're looking for the base. Okay, we are looking for the base on the left side, x. We need to find a way to make the powers the same. So when you're looking for the base, try to manipulate in such a way that the powers on both the left and the right side are the same. So we have x raised to the power of 3, right? Let's try to make this something to the power of 3. Okay, start thinking. 27 is what to the power of 3? 27 is what to the power of 3? Okay, 27 is 3 to the power of 3. It's 3 to the power of 3. So now, what can you see? Our powers are the same. So now that our powers are the same, we can equate the bases. Okay, so when you're trying to find an unknown in the base, okay, try to make the powers the same. So here our x is going to be equal to 3. Our x is going to be equal to 3. Okay, so I want you to understand the basic concept. If you're looking for a power, an unknown in the power, what you need to do is make the bases the same. Make the bases the same, then compare. If you're looking for an unknown in the base, make the powers the same. Manipulate until you make the powers the same, and then compare. Now, this equations involving indices requires some kind of autonomy. So you have to be innovative. You have to be able to, reason and figure out things and think critically, analyze and, synthesize and, what other thing ends with eyes. So it's very important. It's very, very, very important. So let's just summarize everything that we have said. These are all the laws. I'm just going to bring them out one after the other. You can just read along. So these are all the laws. You can just read through each and every one of them and see if you're familiar with each one. Very, very important. Very, very important. Then all that is left now is practice. So these are all the laws. These are all the laws. Of course, there are variations of the law. There are some variations of the law that I haven't put here because there are so many ways you can vary these laws, but these are the foundational basics, or should I say these are the basics. That's a bit of tautology. So these are the basics anyway. Okay, these are the basics. Okay, so let's move on. Remember that x must not be equal to 0. Okay, so those are our laws. So I want you to try this out in the spirit of practice. In the spirit of practice, I want you to try this out. So you simplify this, and you solve this equation. And you can try to visit quizzes.com if you so please and play some games on indices. So you can just play some games if you want to. Okay, yeah, so that's the end of our class for today. I just want to say happy Independence Day to Nigeria, and today happens to be my birthday, so happy birthday to me, and happy wonderful day to every other person. Okay, so I'll see you guys again, same time, same day next week. So don't forget to subscribe. You can like the video, share to your friends, and have a lovely day. Bye bye.